everyone, welcome back. In this particular video, we will be discussing the problem find if there are two elements in a sorted array that add up to a given target. So, first, what we will do, we will discuss the problem statement in the first milestone. Then, we will go towards the problem approaches which we can do to solve it. And then, we will find out the most optimal approach or the one of the optimal approach to code it. Actually first write the pseudocode, that is instruction manual, and then actually code it in the next video. So starting with the first milestone itself, that is reading the problem statement, understanding the sample input and output. We are given a sorted array of integers. Specifically in this question, it is mentioned we are given a sorted array. So we have to assume it is sorted. A sorted array of integers and a target value as input. Given these two inputs, what we have to do? We have to find if there is a pair of elements that add up to a given target. That is, two elements in the array whose sum will be equal to the target. Return true if such a pair exists, or you can say it is found, otherwise false if it is not found. So a very simple problem statement, self-explanatory, but still, let's take an example input to actually completely understand it. Let's say there are five elements in the array. The number of elements is five. Let's say the five values in the array are 2, 4, 5, 8, 9. And as you can clearly see, the array is sorted. It should be sorted. And the target value, which is given in the input, is 7. Is there any pair with value 7 in the array? And I can say, yes, it is. 2 plus 5 will be 7. That's why 0th index plus second index, that is having value 2 and 5, will be adding up to given target. That's why return true. Or you can say output is present, although we have to return true or false. But what will happen if the target is not present? Let's say if I give you target as 100 in the same example, there is no pair with the target 100. There is no two elements whose sum is equal to 100. So return false in that case. So I think problem statement is clear to everyone. Constraints, as you can see clearly, is the array dot length will be 10 raised to power 5, and the value of each of the element present in the array will be at max 10 raised to power 6, and every value will be positive. So what we have to do in order to solve it? Any brute force approach which comes to our mind? See, if I take the array, let's take 2, let's take 4, let's take 5, let's take 8, let's take 9. Let's take the same array which is given in the input. And let's take the target as 9. Is there any pair with target 9? How do we figure out it? We can say, since we need a pair, since we need two elements, run a loop for the first element, then run a loop for the second element. And since we need all such elements for A, comma B, we will run a nested loop. So a nested loop where first element will be figured out in the first loop, second element will be figured out in the second loop. So if let's say the first element is figured out using outer loop, that is pointed by left pointer, inner loop will be, let's say, right pointer. So is it 2 plus 4 equal to 9? No. Is it 2 plus 5 equal to 9? No. Is 2 plus 8 equal to 9? No. Is it 2 plus 9 equal to 9? No. Then what we have to do? Then let's take the left element as 4, that is first index. Can I start the right pointer at the same index? In the question, it is nowhere mentioned that we cannot take the same element twice, although we have to assume something, whether we can take the same value twice or not. So for now, what we are doing is we are assuming that we are not going to take the same index twice. The two elements should be distinct, although it should be mentioned somewhere. But as part of a question, if the assumption will go wrong, then we will get a wrong output. But the assumption for now is that the two elements should be having different indices. All the values can be same, but indices should be different. So is a 4 plus 4 equal to 9? No. Actually, we do not have to check 4 plus 4. Why? Because we cannot take the same indices. Is 4 plus 5 equal to 9? Yes. And as soon as we are able to figure out it, we will return. But what will be the worst case time complexity of nested loop? As you can clearly see that one loop for one element, another nested loop for another element, n into n. Worst case, it will go n square. Although it is not exactly n square, but it will be n into n plus 1 by 2, 1 plus 2 plus 3 up till n. Still, it will be quadratic in nature only. What about space? Since we will not require any extra space, we will take constant amount of time in constant amount of you can say complexity in the space. That is only 2 pointers. Only you can say 4 bytes, 4 bytes, in total 8 bytes. But the question is, can we do better? This is a brute force approach, but can we do better than the brute force? And the answer is yes, we can actually do better. How we can do better? we can use the property that the array is sorted. We have nowhere used that property in the nested approach, in the brute force approach. But if we are assuming the array is sorted, which is given in the question, then what we can do? We can actually apply a pointer, two pointer actually logic, a two pointer technique. Now, what is a two pointer technique? We will say that instead of running the both loops from left to right order, first loop also from 0th index to last index, second loop also from left plus 1 till right index or n minus 1 index. Let's run the first loop, or you can say let's run the first pointer from left to right only. But what about the another pointer from right to left? In that case, we will be able to use the sorted nature property. But how? What is the current sum? 2 plus 9. Is it equal to target? No, it is 11. It is greater than target. What should we do in order to make the sum target? We have to go to 9. In order to go to 9, what should we do with 11? We have to decrease it. Decreasing it by 2, that is subtracting 2 will make it go to 9. What should I do to make it go to 9? Decrease it. But how can I decrease it? Should I make the 2 replace with 4 or 5 or 8? No, it will actually increase the sum. It will become 4 plus 9 instead of 2 plus 9 or 5 plus 9 or 8 plus 9. Versus if you will replace 9, that is 2 plus 4, it might be the sum. 2 plus 5 might be the sum. 2 plus 8, it might be the sum. It is decreasing the sum. So we will replace the value which is at the right pointer, which is having higher value. So if the sum is higher, replace the higher value or discard the higher value. How can I discard the higher value? Now what is the next highest value possible? It is just as the previous index. It is just at the right minus 1th index. So I can do what? If the current sum is more than what we need, we will do right pointer minus minus. Again ask 2 plus 8. Again it is higher. 2 plus 8 is 10. We need 9. We need one lesser sum. So again, in order to decrease the sum, we will discard the highest value. That is, discard the value 8 and try to figure out the new pair, which is 2 comma 5. So I will again do right minus minus. But now, if you will ask, what is 2 plus 5? 2 plus 5 is only 7, and 7 is what not what we need. 7 is actually less than 9. We need an increased sum. And in order to increase the sum, we need to basically discard the left value or the right value. If I will discard right value, I will decrease the sum 2 plus 4. But if I will discard the left value, I will increase the sum. I will make it 4 plus 5. So discard the smallest value from the array. That is, do the left pointer plus plus, because smallest value discard means left pointer will go to the right side. So in this case, we are doing left pointer plus plus. And now as soon as I will see that 4 plus 5, is it equal to the target 9? Yes, it is. So found, target found, return true. What will happen if let's say target was not 9, target was maybe 8? So in this case, 11 was greater than 8, 10 was greater than 8, 7 was less than 8. 9 is also going to become what? 9 is also going to become 4 plus 5 will be 9. 9 is also going to become more than 8. So in order to decrease the sum, I will do what? I will say right pointer minus minus if target is 8. Right pointer minus minus. But as soon as I will make the right pointer minus minus, what will happen? Left pointer and right pointer will go to the same index. And according to the assumption which we have made, we cannot take the same index twice. We have to take different indices to add up to a given target. So as soon as the left and right pointer becomes equal, or even if you can say left pointer becomes more than right pointer, then we have to stop. So till when should we run the loop? Till when should we run the logic? Only till the point left pointer is smaller than right pointer, only till that point. So I hope the logic is clear. What will be the time complexity? As we are only running a left pointer from left to right, right pointer from right to left in a single loop for overall the entire array length, it will be order of n time complexity, linear time complexity. And what about space? Since we are again not going to take any extra data structure, the space will be constant in a nature. Constant space, no extra space is required in place solution. So that was the logic of two pointers and the most optimized solution actually. So with that, we are going to write the instruction manual for the same problem. What we are going to do, initialize two pointers. In this problem, already the array is sorted. So let's directly initialize two integers, which are left as a 0 and right as what? As n minus 1, last index. K is what? K is the target value actually. So what we need to do? We need to run a loop only till the point left is smaller than right. Why? Because as soon as the left becomes equal to right or more than right, there is no more pair left. First, we have to take the sum as what? As the value at left plus value at right, array of left plus array of right. It can be three possible scenarios with whether the sum is equal to target, that is equal to k, whether the sum is smaller than target, or whether the sum is greater than target. So sum is equal to target, that is the first case. If sum is greater than k, that is second case, and obviously last case will be else. Now, what we have to do for the sum equal to k? We can say since target is found, what do we need to do? Return true that found. The target is found, the pair is found. If the sum is more, we need to decrease the sum. How I can decrease the sum? By making the largest value discarded. How can I discard the largest value? By making right pointer go to the left hand side. That is, make the sum smaller by making right minus minus. And obviously, in the other way around, if we have to increase the sum, discard the smallest value. How can I decrease the smallest value? Discard the smallest value by making right pointer shift to the next element, that is left plus plus. But if this loop runs entirely and we are not able to return true at any point, that is no pair found, what should we do? According to the question, we have to return true or false, whether target is found or not. So I will say return false. So this is the pseudocode in milestone number 3. With that, we have completed the instruction manual.